Hello everybody, welcome to Pi Day. Oh shoot, I completely forgot I am missing the little overlay that's going to tell us what's actually going on. Let me go to that really quick. What is it? OBS task list overlay, and it's node server.js, I think. Yeah, all right. Now let me switch back. Hold on, I'll go back to the countdown for just a second. Okay, there we go. Now we got an overlay that shows us what's actually going on and reminds me what I'm actually supposed to be doing today. So anyways, I'm Jeff Geerling. Welcome to the stream. Today we're going to go back over something I streamed last week, I don't know, 2 weeks ago, something like that. Basically, I set everything back up like I had it in that previous live stream, and I found out a couple different things. One thing is that hardware RAID controllers want to protect you from yourself. So they don't let you do things like mix together SAS, spinning SATA hard drives, and SSDs all in one RAID array. It's not a good idea, but I'm not always about a good idea. I'm about what's interesting and fun. Also, the power was an issue. I had trouble getting all of these SATA drives powered up and these SAS drives. One thing is SAS drives don't actually power themselves up like on their own when you plug them into power. They wait for a signal from the controller to turn on, and that was part of the problem I had. The other problem was these drives didn't power up. I don't know exactly why, because I retested this cable a couple times and it kept working after that stream. So I guess, what is it, Goodwin's law, or I forget which law it is that says that anything that Murphy's law, I guess. Anything that can go wrong will go wrong, especially when you're live streaming. Anyways, I have it all set up again, and we're going to get back into that. But today is Pi Day, for anybody who doesn't know. It's 3/14, March 14th. So most years, a lot of people celebrate by eating pies, like you saw in the little intro, or there's a lot of other ways that you could celebrate as well. But yeah, chicken pot pie works for Pi Day too, but we actually had a pie. The picture that you saw in that little intro is actually the pie that I just ate a few minutes ago. I didn't eat the whole pie, but my wife made that. It's been a tradition since we've been married. Every year we have a pie with a pie on top of the pie. This year it was chocolate pie, mostly because we knew the kids would like that more than anything else. Yeah, Murphy's Law, what must happen will happen. I guess what must happen is that I can never get a live stream to have everything go well. But let me, actually I need to move my windows around here a little bit, just because I can't see everything, and I need to be able to see everything to be able to do this thing. Hold on. Okay. And another thing that's special about today, no, I didn't make pies for everyone on the live stream. That would be crazy. Another thing special about today is if you look in the description of this video on YouTube, there's a link to the Pi Foundation's donation page or support page. A lot of people don't know this, but the Pi Foundation doesn't just make Raspberry Pis. In fact, they split up, and the Pi Foundation is in support of educational computing and teaching computing in schools, things like that. They actually do live streams and all kinds of things to help teach kids, especially, how to use computers and how to use technology and build things. And all of the hardware helps support that, but the Pi Foundation does that part, the outreach and support and education. And Raspberry Pi Trading is the company that actually does all the hardware build and production and assembly and manufacturing and distribution. So a lot of people don't know that, but I do encourage you, if you would like to support that mission of getting more kids interested in technology and computers, the Pi Foundation is a worthy cause to support. So all the stream revenue, I mean, maybe 10 bucks, 20 bucks, I don't know how much. YouTube is not, you can't just make YouTube videos and make a living off of it. There's a lot that you have to do to be able to support yourself if you want to do YouTube stuff. But whatever revenue that comes in from today, not only the stream, but any of the other videos on my channel, in addition to any super chats that somebody might want to put in, anything that I get, any new sponsorships, any merch sales. If you go down under the video, there's also some merch on the redshirtjeff.com store. Anything that I get today, I'm going to donate, and depending on how much it is, if it's like $10,000 like Linus on LTT, I can't match that, but I'll try to match that and double it and donate that to the Raspberry Pi Foundation. Anyways, so that's today, that's Pi Day. I want to talk a little bit more about what went wrong last time. So specifically, I guess I'll go over, let me switch camera so I can point to things. I got my little gimbal and I just noticed it's actually like slightly off center. So that's a little annoying. And I didn't switch to the camera, so you can't even see it. There it is. I'm going to switch to the desk camera, which I switched it up today so you can see a little bit wider view. I have the Raspberry Pi Compute Module 4 in the official I/O board. It's plugged in using a 1X PCI Express to 16X adapter. And this is the, I forget the model number, Mega Raid. I can look at it right here. The Mega Raid 9460-16i from Broadcom. This card was sent to me by Broadcom because they saw an earlier video I did on older cards, and they said there's no way you're going to get one of those working on the Pi, but this one might. So they actually sent over some experimental drivers, and I had a couple engineers who worked with me on getting the driver for this card working on 32-bit and 64-bit PiOS. I have a whole video about that. Maybe later I'll try to link to a card up over here on the screen to that video. Anyways, you can find out more about this card and how it works with the Pi and how we got those problems solved. But this is plugged in, and then I have the first two connections here. These are mini SAS HD, I believe, these little guys. I'll get a close-up of that for you. Because it can get confusing when you're talking about storage standards. Mini SAS HD, and if I'm wrong, you can comment about that. Yeah, somebody's asking, what is OBS? OBS is the streaming software. Ooh, that's fun. OBS is the streaming software I'm using for this live streaming. And I built this overlay. Well, I mean, you can see it on the stream itself. I don't have to point at it on my screen. But I built that using Node.js and some HTML and CSS, so that's kind of cool. So anyways, Mini SAS HD, this one is connected to this backplane, which I also talked about, and this little lesser-known YouTube channel, LTT, also had a video featuring this. It's called Elrond. I didn't mention that in my video, but this is internally called Elrond. You can't buy this, unfortunately. A lot of people would love to buy it, but you can't. This is an experiment. It's not experimental. It's like a proof of concept backplane that shows a new technology, U.3 tri-mode storage, where you can pop one of these drives out. So I think there's a SSD in here. This is SATA. But you can pop it out, and you can pop in a SAS drive, or you can pop in a U.3 NVMe drive. And this controller card, in tandem with that backplane, will just do everything it needs to switch between the three standards. So it's cool for enterprise storage where people might be switching slowly over time from SAS to NVMe, or they might want to have some servers with SAS and some with NVMe, and they don't have to worry about having like all the different backplanes for all the different types. Anyways, that's this backplane. It has eight ports. The backplane is modified. You can't buy one of these from Serial Cables. They actually discontinued the model, but even if they didn't, this is modified. The board inside of it is modified to work with that tri-mode backplane. Then I have, this was sent in from Germany. I forget who it was. It's in a GitHub issue. Anyways, this was sent from Germany. There are four, what are they? Let's check it out. That's the backside of the drive. 4 Fujitsu Sun Microsystems branded 73 gig 10K SAS drives. These guys are kind of loud and still dusty. I haven't actually cleaned the inside of that thing out. I probably should. And then these 4 SAS drives were purchased on eBay. They're server pulls as well. They're nice and loud. Some HP 10K SAS drives, 300 gigs. All right, and hopefully there's no echo today. I don't see people saying much about that. Oh shoot, that's not actually plugged in. Let me switch cameras. It's really hard to do this when you're holding a gimbal and the hard drive is now. There we go. Okay, let's try plugging you in the right way. All right, and then finally over here we have 500 gigabyte WD Green drives. And there's a little joke about them in a video coming up. But yeah, I know WD Green drives are not like enterprise grade. In fact, if you pull these things out of old servers, that's probably not new enterprise grade either. The funny thing is about this, even though these are the cheapest drives of the bunch, these Kingston SSDs, they're probably some of the more reliable because they're not like 10 years old coming out of servers. Anyways, that was the drives. Those two are connected to simple mini HD mini SAS to SATA/SAS connections, just these little 4 guys. So that's this cable here and another one over there. And in that other video, in the previous live stream, I showed connecting this all. I think the other thing that was tricky was power. And like I said, I don't know exactly why those four SATA drives weren't turning on, but they are now. And I have them, this power supply at 700 watts, it's not the best power supply in the world. It's not the worst either. But it says that on the 5-volt rail, it gives 100 watts, 12 volt, 696 watts. And 5 volt, here it says 15 amps. And 12 volt, it's saying 58 amps. So I don't know, I guess, yeah, I mean, that's enough power to power a lot of hard drives, more than this. And this guy has its own power supply in it. So something was weird with this. It wasn't powering up these drives. The other thing that happened was because these weren't sucking down power, this power supply turns itself off, as many do, after a few minutes if it's not seeing that any power is being used. So as long as there's power being used, so your drive is powered up or it's powering the Raspberry Pi, which I could power the Pi through here. I'm not doing it in this video, but I can do that through the 4-pin floppy connector with using a Molex to floppy adapter. I mean, I don't know of any modern power supplies that actually come with floppy connectors anymore. But anyway, I also had in another video I talked about making this little guy. I bought a fully modular power supply like this because I'm not going to use it in a PC. I probably never will, but it's nice to have these power supplies because they provide a lot of power. You could power a lot of things at the same time, and they provide clean power, which, you know, you can use a bench power supply, but they're bigger and bulkier. And but the downside to these is they require you to short PS on the ground to turn it on, and they make breakout boards and things like that. Everybody's mentioned that in the comments. I know that, but I made this little guy, and the problem was that I had a couple other wires out here that were probably like 12 volt or 5 volt. They shorted, they blew that other power supply, and that guy's gone. So, and it was 600 watts. This looks like the exact same hardware, so I don't know how they uprated it from 600 to 700 watts, but whatever. So we're going to turn everything on, see what happens. I turned everything on with power, and everything spun up. So we'll see if that works today or not. But I'm going to switch on the power supply. Now that it doesn't turn anything on because that's just the internal power supply switch. I'm going to plug this in, and we should hear it click. There we go. And you can see these lights came on. And I can feel these now are vibrating. They're spinning up. I should probably have this flipped over because this side has that like a little padding on it. Tofu with seasoning. Yeah. In the previous video, I made a joke about tofu. Apparently that offends a lot of people who love tofu. So sorry about that. I've only had tofu a couple times. I didn't really enjoy it that much. But looks like everything's working now. These are not powering up. And if I'm close to them, you can't hear anything. And these are quiet enough. They're actually nice and quiet drives, which I like. Usually my stuff is all in this office with me, so I like having quiet things that aren't super loud. But I'm also going to turn on this guy, which you might be able to hear that over the sound of my MacBook Pro's fan down below that's making a lot of noise. This guy down here on my rack, he's been working hard doing the streaming. Someday I might build like a separate streaming PC, we'll see. But these drives are all on, and it's time to plug in the Pi. So I just have it plugged into Gigabit Ethernet here on my home network, and I have I have a light version of the Compute Module 4. So I have this micro SD card. I don't know if this camera even, I guess it autofocuses. Look at that, that's nice. Anyways, I got the light version, so I have a micro SD card that I'm going to boot from. And NVMe boot is actually now supported, but not through PCI Express switches, which is a little annoying. This card gets kind of hot, so I have the fan, the Noctua, blowing over it. It's not a ton of air. In a server build or in a long-term setup, if I built a case for this, I would probably want to move a lot more air over this because it does get up to 60, 70 degrees Celsius. And enough to make your hand not want to touch this. Anyways, this is booting up. It's going to take a couple minutes because this has its own ARM processor inside of it, and it has to do its own boot process. And, well, let me grab this camera because I don't want to grab the running card. You can see this little light is blinking. That's kind of like its heartbeat, like I'm alive, I'm starting to work, but it's still booting up, and you can actually hear these drives. I don't know if you can hear them spinning up, but I can hear them spinning up. Here, I'll come closer. Yeah, so all the drives have spun up now, and that's something that these hardware RAID cards actually do this for you, which is, I mean, a lot of people are like, oh, hardware RAID is stupid, it's old-fashioned. It does a lot of things that are important, especially in enterprise. If you do have a lot of spinning drives, you don't want all those spinning drives to boot up at the same time. You're going to have a power surge, your power supply is going to get fried, or everything will just break completely. But it's funny too. This morning I noticed on Serve the Home, another YouTube channel I follow, on Serve the Home there was a video about I think it was 100 hard drives, a Dell enclosure. Oh, I need to step the overlay one. Yeah, sorry about that. Reveal the setup, turn everything on. I am so bad at that. Anyways. So on Serve the Home, there was, I think it was 100 hard drives or something like that, a 1.2 petabyte 5U rack mount server with Dell. And if you can imagine 100 hard drives all spinning their motors at the same time, that is a lot of current. Like you would need like 2-gauge wire going into that thing to be able to provide enough power to actually spin all this up. So what hardware RAID cards like this can do is they can intelligently know, like there's 100 spinning hard drives, spin up 2, 4, 6, 8, like that over time. So that's another thing that they can do. You can do some of these things with software RAID solutions and different kinds of setups, but when you're going for full enterprise and reliability and things, hardware RAID does have a lot of benefits that are harder to get with software RAID or sometimes even impossible. Anyways, it looks like everything is working. So what I'm going to do is switch over to my screen. And everything is working, so I'm going to step to the next step. We're going to use storcli to try to get, try to see everything. I'm going to SSH into the Pi, and I think I did this last time I was on here. Show all. All right, so we're going to look at what this thing can see, and that's a lot of hard drives. All right, and it's showing virtual devices. So I did set up some drives or some RAID arrays last time. I think what I'll do is delete them all and recreate them. These are all just the capabilities of the controller. My microphone has excellent noise cancellation. Yeah, I was thinking of setting up a secondary microphone over here just so you can hear, well, you can't see what I'm doing. I was thinking of setting up a secondary microphone somewhere over here so you could hear everything, because these 4 drives in particular sound like a freight train going down the highway, or, well, that would be very dangerous actually. A freight train going down the tracks when they're doing a lot of work. And when we do that, I'll try to get this microphone up closer to them so you can hear it, but it's kind of fun to hear. Anyways, let's see if my mic mute works this time. That looks like it actually did work. That's great. Now you don't have to hear me drinking my water. I should put a red shirt on. If I put a red shirt on, then I would have to break something, and I'm trying to avoid that right now. Maybe we'll figure out a way to do that later. Little box at bottom right. Oh yeah. Yeah, I'll show you a couple other things really quick too. And I think I set the stream on, what's it called? I set it on to like long delay mode or something, so my talking is about 30 seconds off from chat, unfortunately. I wish it were not. But yeah, over here, so this is like where I do projects. And I mentioned this in another video. This is why I love the Raspberry Pi. I can do pretty involved projects like this, using a Raspberry Pi in the corner here, I don't have to have a giant PC. You know, every time I watch a video on like Linus Tech Tips and they have this gargantuan PC and a huge build desk and stuff, that'd be great if I had a lot of room. But this, you know, this is where I work and do all of my everything besides like family life. So I don't have a ton of room. So using a Raspberry Pi lets me do all this. So I have this little charger over here, and I have like a lightning charger for Apple stuff, and I have two USB-C chargers, HDMI cable that pops over to this monitor, a USB extension for my Mac that right now is plugged into this camera. So it's nice to have this set up, and I can do a lot of different projects. I'm still trying to figure out a way to incorporate a DC bench supply so that I can do some of that stuff over here too. I don't know. At some point, later this year, I'll probably talk a little bit more about my office setup and something that I'm planning longer term that might involve a new build out in that part of the basement. Anyway, stay tuned for that. But we're going to take a look at these drives. So here it's showing all the drives and all the arrays that I set up. So I do have 4 RAIDs. Apparently I called 3 of them Super RAID. Should probably use a unique name for each RAID array. That was silly of me. And then there's the Crazy RAID down here. This one I think is those four dusty drives from Germany. But anyway, so it sees all these, and they're online, which means that they're part of a RAID array. If I plugged in a new drive to this hardware RAID card, it would show up as ugood, which last time we realized if you read this documentation, you actually get to learn like what things are. And here it was, what is it? Somewhere in here it says ugood. I don't know where it is. Now that I'm talking about it, I can't find it. But somewhere in here it says ugood is like, it's good and it's working. Oh, here we go, physical drives. So here's all the drives. We got SATA, SSD, these are the Kingstons. 2 of them are 120 gigs, 2 of them are 240 gigs. Someone's asking about oh, thanks for the donation. That'll go straight to the Pi Foundation today, of course. Somebody asked about the cable organizer. I got it on Amazon. It's from AKWOX. AKWOX? I don't know. I just bought it because it was going to be quicker than routing out my own out of a piece of wood. Sometimes I do that. Call one of them Gatorade. Yeah. So we got those 4 SATA SSDs. Then we have the SAS hard drives. These are 300 gig HP. And these are all in the enclosure. So the enclosure is 97, these drives here. And then, and I'll show you, so there's the SATA SSDs, the SAS hard drives, and then we have these 4 SATA hard drives, and these are the 500 gig Western Digital green drives, which are all in here. And then we have, let's see what else we got. These are the 73 gig Sun branded Fujitsu drives, which are in here. And I don't know why they're blinking so much. Maybe it's still setting up that array. Does it say anything about the status? It says they're online. I don't remember what the command is in storcli. Thanks for the SECs. It's SEKs for the Pi Foundation. Let's see. Oh, the 3.5 inch enclosure. So this guy, this is I think they come in 2 packs, and maybe I could put a link to that later on Amazon if I remember. They come in 2 packs, and they're meant for putting into a PC, but they make a pretty nice solution for just throwing 3.5 hard drives somewhere. But they come with these little grommets, so it's isolated. You don't feel much vibration on here, but I can feel the hard drives themselves. And they have a lot of ventilation, so if you need to cool them off, that works out too. So I liked it. I even put 8 SSDs in it one time. I put in little trays in each one that held 2 SSDs, 2.5 inch SSDs. But it's nice and it's pretty good hardware. But yeah, I'll try to put a link to that on there. ugood unconfigured. Okay. Yeah, somebody found. Oh, there it is. ugood. No. There you go. Ubad is unconfigured bad. Ugood is unconfigured good. Okay. We found it. And I was not sharing my screen, so you're not seeing that. And also I'm realizing that this overlay is on top of everything. So let me move it over here. And what I'll do first is I'm going to delete these volumes, because now that we know how this all works, I'm going to drop them all. All right. You can see that there's activity, so that's good. All right, so it looks like the deletions happen. Let's show everything again. And up here, yeah, I'm not seeing any volumes that it's using anymore. So we just deleted everything. Now I'm going to create some volumes. And like I said, I can't create one array between the SATA SSDs and the SAS drives. And these, I might be able to create an array between these SAS drives, but I'm not sure because they're on different ports on the controller. I think I could, but I'm not going to try that right now. I'm going to try something more fun. And then these are SATA hard drives, so even though these two are SATA, you couldn't put a RAID array between them because hard drive and SSD is incompatible. Like I said, in software RAID you can do these things, but these hardware RAID controllers are meant for professional solutions, not for hack together things that shouldn't really be in production. Fantex, it looks like, stackable hard drive brackets. Yeah, they're pretty cool. I like them. It's sometimes you buy something from Amazon and you're like, this could be bad. But in that case, it was like, these actually work nice. They fit perfectly with all the different drives I've thrown in them, including some drives that I'll be talking about in a video that involves these things over here very soon, and the focus is on my hand, so you can't see that. Anyway, I'm working on some of that stuff for a completely Pi-based 2.5 gigabit NAS to see if an Open Media Vault NAS solution is comparable to an actual production NAS that you can buy, like a QNAP or Synology or something like that. Anyways, I'm totally off track. Let's get back to creating some RAID arrays. So I want to add a virtual VD virtual disk. I don't remember. RAID. I'm going to do RAID 0 because we're just going to have fun today. It's Pi Day. We're just going to go YOLO, and if one of these drives fails, everything's going to fail. That's the goal at the end of the day. So we're going to do this. First one will be these four guys, the 73 gigs. So I'm going to call it, how about Gatorade? Gatorade is good. And these are 98, these are these ones. So 98, 12 through 15. So that's the one. And I don't think I need this, that I can just use the default for that. Strip is 256 because they're SAS. I think the default is 256 on storcli anyways, but I'll just specify it anyways. 256 for hard drives. So let's create that one. Okay, created. Now we're going to create another one. RAID 0. Give me some suggestions for more RAIDs. 4 guys RAID. I'll spell it out. 4 guys RAID. Sure, that's fine. We'll do this one. I'll do the 4 SATA drives. So those are up here. 97, 0 through 3. Okay, 97, 0 through 3. And we'll do 64 since there's SSDs a little faster. All right, created that one. That was fast. That was a little faster because they're SSDs. And one of the reason I'm not doing RAID 5 or 6 is I don't want to wait like 12 hours for the parity calculation or for the initialization and synchronization to complete. That's just boring. So I don't want to live stream that long either. I have other things to do today. So let's see. This one we'll call, what should we call it? Braid. I like that because last night one of my girls got braids in her hair. She doesn't really often do that, so it was fun. It's like different. Okay, so that one we'll do these 4 SAS drives. 97, 4 through 7. 4 through 7, and these will be 256 because they're spinning drives. Can't type. There we go. Okay, that's those 4. And we're going to do another one, radiator. I like that one, radiator. And that'll be these 4 SATA drives at the end. These guys, 98, 8 through 11. 8, whoops, through 11. Okay, so it looks like we have 4 RAID arrays. Okay, these are our 4 RAID arrays, and they are all online and cached through this storage controller card. So the next thing that I'm going to do is use FIO to run a test. And we're not, in this live stream, I'm not trying to get like the test that would go into a published blog post review about it or something, but we're just trying to have some fun. So I'm going to look at what I have here. So I'm going to move this 1024 random read .fio. I'm going to move it to 1 meg read.fio and move 1024 random write to 1 meg rand write. And you'll see in the output megabytes and megabytes. I'm not going to try to translate it because I always confuse myself when whenever I talk about megabytes, megabytes, or any kind of bytes, I'm always thinking in terms of like 1024 kilobytes is a mega. I hate marketing. Anyways, marketing has ruined hard drives forever. It used to just be a megabyte's a megabyte. A megabyte is 1,024 kilobytes, and kilobytes 1,024 bytes. The world was simple back then. Nowadays, marketing people decided that they wanted to make their hard drives look bigger, so they invented this new thing called the megabyte, which is not actually 1,024 kilobytes. Anyways, rant mode off. So we have a couple FIO configurations. And FIO, you can look it up online. There's a few different ways you can test I/O. I often use I/O zone, mostly because it's a little safer if you're doing write tests. FIO can blow up your hard drive if you try doing it on a live hard drive and force it. FIO tries to prevent you from doing that, but anything that tries to prevent me from doing something, I tried to find a way around it, and I did, and then I realized that it just nukes your hard drive. So don't use FIO to do write speed tests on an active RAID array of any type. That's not a great idea. Anyways, we have these two, so I'm going to remove the 1024K one that I was using before. I don't need these storcli things either. Oh, it's write protected. I didn't know that. All right, anyways, we have these things, and I have the command that I ran to run FIO here. So if you want to reproduce this result, you can at some point. And I'm going to do 1 meg random read. I don't know which device this is actually going to hit. Let's see. Go to desk. It looks like it might be hitting the SATA SSDs, which that's boring because they're silent. So maybe we'll actually try to do a different drive here. And let me open up that configuration and see what's up. Is somebody jumping above me? That is highly likely to be happening. I showed it in another video at some point, but above me, so this ceiling is actually the floor of the children's schoolroom / play-ish room, I don't know. And then I'm in the basement. So you can see way over there, there's a window to the outside. That is the only natural light I ever see for 8 to 10 hours a day, depending on how long I'm down here. If I'm making a video, I'm down here for an extra hour or two at night. Anyways, yeah. So right above me, that is kids running around all day. Before I put in these lights, I actually would get some of the insulation that I blew in here. It would fall through the little hole and land on me when the kids were running around. But that doesn't happen anymore, so that's nice. All right, so it looks like the SSDs they saturate the bandwidth of the Raspberry Pi. The Raspberry Pi has a 1-lane, a by 1 PCI Express Gen 2 slot. So theoretically it can pump through 5 gigabits, which 5 gigabits is what, 425 megabytes, megabyte, I hate marketing. Anyways, this is basically saturating the real world throughput that you can get through the Pi's bus. So that's one other advantage of using a hardware RAID card is it can handle all the storage bytes being swapped between drives and things, versus the Pi would have to go through the CPU, and there might be a little more overhead. And I usually get more like 400 to 410 megabytes per second. I'm sorry. If I'm using a SATA controller and it's using software RAID maximum. And these numbers actually go down a little bit if you're using something like RAID 5, where this card actually can provide a lot more processing power to calculate parity versus doing it through the Pi's CPU, which is a little bit slower. So let's see. Yes, that is a serious door. This door actually came from a radio station. It's funny, a lot of the best things I have in here came from some old radio stations that closed. You got to find an industry where they're consolidating, and you get things like this. Like, they were going to throw it away. So I was like, well, that's like I don't know, probably $1,000 door. So I went to the radio station, picked it up, threw it in the minivan, brought it here, and now I have like a really nice door that's solid. And I mentioned in another video, this voice processor down here also came from another radio station, so that was a nice pickup. And you know, you can get some cool things. And these sound panels back here, you might think that's just decoration, but it helps with noise reflections. So those all came from a radio station as well. All right, so that's the SSDs. It's no surprise that they can saturate the bus at RAID 0. Let's edit this. One rand read. Why is that not working? Read.fio. Oh, 1 meg. Nope. 1 meg rand read. All right, so this was on dev SDB. Let's do SDA, which LSBLK. Let's see what we got. So SDA is 271. So this is SDA must be this guy. SDB is those SATA SSDs, which are here. SDD must be the SATA. Okay, it must have been in the order that I created them in the RAID utility. Oh shoot, I'm sorry, we're benchmarking. There we go. Yeah. Sorry about that, everybody. Yeah, just keep reminding me because I will forget again and again. Yes, yeah, we're hitting USB 3 speeds, but if you use it, so another thing that some people mention is, oh, I can do all this stuff on my Raspberry Pi 4 just using USB 3. Yes, you can, but there's a couple, first of all, you can't do hardware RAID through USB 3, that's impossible. Second of all, there will be a little bit of overhead because the Pi has to go from PCI Express to USB, and then usually like USB to SATA or USB to NVMe. So there's 2 conversions in there, and it's not a ton of overhead, but it is enough that you will see an impact, especially when you're talking about like a RAID 5 array or something like that. Anyways, let's see. So we're gonna do, I keep distracting myself. What are we on? We're on SDA. So we're gonna run that benchmark now, same thing, but this will be on SDA. And let's see if I can hear this one. So, I don't know if you can hear that or not. Tell me in the live chat. And you can't see it. There we go. I'm just trying to get this microphone closer. So yeah, that's what those sound like. Why is hardware RAID impossible through USB 3? Because you need a hardware RAID controller like this. I mean, there might be somebody that makes, I've never seen one, a hardware RAID controller, especially like enterprise grade, that does all the RAID operations in its own chip through USB 3. You'd have to like have a separate computer basically. I mean, this, in a sense, this is its own computer. It has its own RAM, it has its own processor, and it just communicates with the Pi over PCI, but yeah, you can't really do that. Anyways, you can see this is taking a lot longer. If you look up here, it's definitely not, these drives, I believe, these guys here are SAS. They're not SAS 6 gig. They're not SAS 12 gig. They're SAS, like the original old school SAS, like the first one. So they're maximum 3 gigabits per second. And you can see that they're a lot slower. And if I switch over to, so let's do that. Let's go over to SDC, which I believe is these guys, which are the SAS drives. If I go there and save that and run it, again, I'm going to lean over here, I'm going to hit run, and you can hear them somewhat. They're actually quieter today than they were, so maybe by using them more, they're starting to get a little bit better. But you can see that they're actually faster. So here was the other one. It was 115 megabytes per second. This one is getting like 30, 40 megabytes per second faster. These are SATA or SAS 6 gigabit drives, so these are like the second generation drives. But yeah, all this stuff is really old SAS drives. And Josh is basically saying you're hitting the drive rotation rate. So these are all 10K. But these older ones are not only 10K, but they're like the original SAS standard, so 3 gigabits per second max. And it's doing random reads, so it's going to be even harder on the little read heads and making sure they seek to the right spots. Is it successful yet? So far, we have 16, so I'll give a little status update. We have 16 hard drives, all recognized. They're all in RAID arrays. They're not in one RAID array. We might get to that soon. But we have 4 over here. 8 in this unit. This is called the Elrond. This is a backplane from Broadcom that they sent me that shows off a cool feature that I haven't been able to completely test yet. I hope to do a video on that sometime, talking about PCI Express, NVMe, plus SATA, plus SAS, all in one. And then I have 4 SATA drives. These are Western Digital green, totally not made for RAID arrays, but that's what we do on this channel. We use things in ways that they're not intended. Like, look at this power supply. I got a little piece of electrical tape covering up the power switch, basically. So anyways, that one, we got 164 megabytes per second, so a good bit faster than this one, but of course nowhere near what we got with those SSDs, 415 megabytes per second. So finally we'll do that last one, SDD, which is these guys over here, the SATA Western Digital drives. And it's interesting to see. I want to see whether or not they'll be faster than those original SAS drives. So we'll save this and run it. And these are all read tests. I haven't done write tests, but we'll get to that at some point. But you can't really hear, I can't hear these. I can barely make it out if I put my head right down next to them. But these drives are a heck of a lot quieter. They're not built to be enterprise storage. Like, I think in enterprise, a lot of times they do things like, you know what, it would save us a little time and a little money and a little power to make it not super duper quiet. So they might take out some of those features. But also, there's only, I think, 2 platters in each of these drives. There might be 3 platters in some of these, I don't know. And these are spinning at 10,000 RPMs. Those are at 5,400 RPM. All right, so actually this is really slow. Wow. So yeah, I wouldn't use WD green drives. This is RAID 0, so there's 4 hard drives. They're doing random reads, so it isn't just reading a sequential file off of them. In that case, they would be a little faster. But yeah, that's slow. Wow. So if you're building an old equipment RAID array, you might want to just go online and buy a bunch of used SAS drives instead of used SATA drives that are cheap. I think the SAS drives were like 18 bucks a piece. The SATA drives were actually 19 bucks a piece because I bought them from Micro Center because I needed them that day for a video I was working on. Go figure. If I bought them online, it'd be like 10 cents a piece because those things, most people just throw them away. And in the chat also, Josh is mentioning some of the stats for PCIe, and it's important to note that this is overkill. This card can put through, I think for those who don't know Josh, who's in live chat, Josh was the engineer at Broadcom, so everybody thank him, who helped me get this whole thing set up and kind of coordinated it. So thank you very much to Josh. But this card, I think, can put through like 56 gigabits. 56 gigabytes or gigabits? I don't know. Josh, clarify that for me. But anyway, this can put through a ton of data. And you can have up to 240 hard drives connected to it. The Pi cannot do that. The Pi is, you know, you're stuck at 3.2, 3.3 gigabits total, which is 420 megabytes, something like that. So yeah, we're hitting the limits of what the Pi can do before this card is even like warming up. But you can see that like these hard drives are so old that they can't even saturate that bus. Neither can these guys. The SSDs can, and if you put more SAS drives in a RAID 0, it probably would at some point. But anyway, let me grab another drink really quick. I'm sorry, I was muted that whole time. Like I said, it's 30 seconds. 30 seconds it takes. I forgot, I usually, when I do these live streams, I usually turn on the like instant mode where I can react to chat. But for this one, I forgot to do that. So I'm like 30 seconds behind. So it's going to be like 60 seconds before you actually hear me again. But anyway, you should hear me now, and you might be able to hear the hard drives. Yeah, you probably can't hear those actually. They're a little quieter. Drinking is muting. Okay, so we got that done. So 131 megabytes per second. That's actually not bad. I mean, that's one of the things, when you get SAS drives, when we get enterprise storage, you end up getting more consistent performance, I'd say, than what you'd get with a SATA drive, which you'll see in just a minute. In fact, let's do it now. I'll edit this and we'll switch to SDD, which is those SATA drives. Save that and let's run it. And you can't hear the drive, so I'm not going to even try to have you hear them, but this is already, we're not getting output yet, which is not a great sign. Maybe one of them blew up. What is my RAID config? So they're all RAID 0, and you know, that's just a, I didn't want to do RAID 5 or RAID 6 because I didn't want to wait for the initialization, and I didn't want to do RAID 10 because soon I want to put everything together, and I didn't want to mix like a RAID 10 with a RAID 0. How about a mic enable button on your drink coaster? That would actually work out well. I mean, I got my, you know, if I could make it so like it's on, muted, I could actually build something like that. Right now I'm using this little guy, the Stream Deck. I bought this a few months back when I realized I would do live streams more than like once a year. And it's nice, but it's not like, it doesn't warn me of anything. It does have the little mic thing glowing there, so I guess that's nice. But anyway, yeah, we're getting off topic. I'll do a video on how I stream at some point. I did one on how I make my YouTube videos, and that was pretty fun. SDB and not SDD. I thought it was SDD. Anyway, that was actually relatively fast. Which array was that? Let's check. Yeah, no, that's these. Yeah, so I'm surprised. I thought it would be a little slower. I guess 4K would be a bit slower, but 1 meg random write is not too bad. But let's go to SDB now, which is, I was just going out of order to see if those SATA drives were super bad. Let's run that. Okay, this one is on, this is the SSDs. It should be fast. I don't know if we're going to get the full bandwidth of the bus or not. We'll see. Yeah, so we're getting close. These SSDs, I mean, SSDs, anybody that's ever used SSDs compared to hard drives knows that they're super fast for a lot of random operations because you don't have to move a head to seek to the data that you're trying to find. And even without caching, a lot of them can be a lot faster. But there are some SSDs that are very slow or have other things that are not so desirable, especially if you're going to be running them 24/7, or if you're alternatively going to run them for a time and then like put them offline for a while and then bring them back online. SSDs actually have some issues with that scenario, unless you buy like the most expensive enterprise ones. So there are situations where SSDs are not the right choice. Anyways, it looks like the write speed was hitting the bus limit again, so you could probably eke out a little bit more performance from those SSDs. Let's try the last one, SDC, since we already tried SDD, and run it, and I think that's these guys. So let's see if you can hear this if I hold the microphone up. It's actually surprising, they're quieter. They seem to be getting quieter as they use them more, so maybe it was just like they were sitting on a shelf for months and months, and literally the first time I plugged this in and turned it on, one of these 4 drives, the entire carrier kind of jumped when it turned on. It was a little scary. Didn't know if it was going to shoot out of the bay or what, but that's what happened. That was interesting. I would say that if your hard drive does that, it might be time to make sure that you have a hot spare running, because it's probably going to go. And if it's RAID 0 like this is, everything's down once one is down. So that's another reason not to do RAID 0 for anything that's highly important, unless you really, really, really just need speed. Yeah, it's Pi Day. McSkins mentions that he forgot it's Pi Day. That's why I'm doing this live stream. I wanted to do it again anyways, just to actually get all 16 drives working. But anyways, all right, so that one was 233 megabytes per second. That one was the fastest of all the other ones, just because these are SAS 6 gigabits drives. So second generation SAS drives from HP that are a little nicer. I don't have any newer SAS drives, and I don't have any NVMe drives yet. Maybe, hopefully I'll get some someday. Can do some cool tests, but if I do that, it's just gonna be this again. We're saturating the bus on the Pi. But it's better to have more capacity than less. You know, I would rather be able to write to these things as fast as possible and not be overloading them, instead of, you know, if I copied over 50 gigs or 100 gigs of data, I don't want them to be working as hard as they can all day long. You get better life if you're not doing that. Let's see. All right, so we got those things. What I'm going to do next, because I can't in hardware put all these drives together. So what I'm going to do, I have them all in RAID 0. So there's a RAID 0 here, RAID 0 here, RAID 0 here, RAID 0 here, and RAID 0. No, the power supply is not a RAID 0. That would be very interesting. Maybe I could build a power supply Pi-based RAID array at some point. Anyways, there's a bunch of RAID arrays here. They're all RAID 0. I'm going to build a software RAID 0 using them all, and it's a terrible idea, but if it works, it might be fun. So that's why I'm going to do it. I don't care what people think about it. Pi Day tomorrow. Where are you, like on Mars or something? I thought it was the 14th everywhere by now. It's 12 hours. I don't know. It's Pi Day here. All right. So what I'm going to do is use MDadmin. Pledge another $10 if I succeed. No pressure. Thanks, Citizen Gold. And as a reminder, I mentioned this at the beginning of the stream. And let me move on to the next step here, because we're going to get the Mega RAID going. It's funny because it's using a Mega RAID storage card, but it's going to be a Mega RAID, like a very big RAID. All the things that I'm getting today, any YouTube revenue, any donations, any super chat, anything I get through GitHub sponsors or Patreon or anything, I'm going to match that up to a certain limit. I can't afford the $10,000 or whatever, like LTT did that one time when he bought some game Power to the Players. What is it? GameStop shares. Is it GameStop? I don't remember. Anyways, I'm not going to do that, but up to a certain limit, I'll match anything that I make today on any of these things and donate that to the Raspberry Pi Foundation. There's a link in the description to that if you want to donate to them directly. That also is nice, because when you do a live chat or super chat or whatever it is, YouTube actually takes a little bit of that revenue out. So, you know, if your goal is to donate as much as possible to the Pi Foundation to help them with their educational computing and all that, then, you know, it might be better to make a direct donation. But just to let you know, that's my plan today, is to donate anything that I get today on Pi Day to the Pi Foundation to help them spread awareness and education and the love of tech, really, which is my goal too. Except I don't only focus on kids, I focus on just everybody who wants to have a fun time and learn some cool stuff. Somebody asked, is it getting hot in here due to all the drives? Yeah, it actually is. I have a thermometer, not a thermometer, it's just a clock on the wall up here. Let me switch to here. So it's saying right now that it is 75.4 in here. Usually it's 72 to 73. So we've raised the temperature of the room 3 degrees. And if I feel this stuff, let's see. So this guy, he's not actually hot. I actually put in, so I mentioned in the video where I talk about hardware RAID that this thing has like industrial blower vac fans in it. And they do get crazy loud if you leave them on. 90 decibels at the back actually, which is pretty loud. But Josh mentioned that there is, you can put in a PWM module for the fans, which was easy to do. It was like 10 bucks on eBay. You can get on Amazon or elsewhere. But anyway, so I did that. So this is not super loud, and it's still sucking in. Like I can feel the airflow right here. I can feel it pulling air. And if it actually is on all the way, you could like probably stick something to here and it wouldn't fall. And the air, if I opened my door, I could feel the airflow beyond the door from this thing when the 12-volt fans were on all the way. This guy has its own little fans. This is a little warmer. I can feel that. If I was hitting it hard with some I/O, it would probably get even hotter. These guys are warm but not hot. Power supply keeps it cool. The power supply has a giant fan on it, so that's a nice thing. And then this card is actually the hottest thing. That's pretty hot. Like I'd say that's probably 60, 65 degrees Celsius, the chip on here. You can actually measure that somehow. But anyway, yeah, that's pretty hot. And I should probably turn up the fan a little bit, give it a little more cooling, but not today. We'll just keep having fun today. Red Shirt Jeff AMA, good question. Let's see. Okay, so we want to make a RAID array, and I'm going to do what I always do when I try doing anything. I'm going to go to my PiPCI website. This is why I develop everything in the open. It's not because, I mean, it's partly because I want to help other people, but I want to help myself. I don't, like you can say man md admin. Maybe it's not installed. Okay. All right, we're going to get mdadmin. So you can use the manual pages and stuff, but I really like examples that I know work. So whenever I find a way to do something, I document it somewhere, and then I can do it over and over again without having to look up the reference. So I'm just going to pop in here, and I'm actually working on this hint for an upcoming video. And where's the command? Just to make a quick array. And I didn't actually document which command I ran. I mean, it's not super complicated. I just wish that the man pages had like an example, like if you want to create a RAID 0 array with SDA and SDB, just do this. Because that's, you know, the man pages document everything, and I just want to know how to create the array. So maybe I'll grab it from one of these other ones. Because my brain does not have the capacity to memorize the arguments for everything. Okay, so we just want to create RAID device, and I'm going to create MD0, level 0, this is going to be RAID 0, RAID devices 4, and SD, it'll be SDA through D. Hold on a second. Let's be okay. SDA through D, yeah, A, B, C, D. So that's what I'm going to do here. We'll see if this works. There are examples at the end. Okay, create the array. Yes. We'll see what all this happens. Yeah, I don't. So here's the problem. I think because the hardware RAID has already set this up, mdadmin might not be able to create an array on top of those arrays, because the disks themselves might have some of that metadata that mdadmin is trying to write to them. So that might not work. I don't know. Does anyone in the live chat know if there's a way that I can stripe these all together in software? Because unknown error 524 isn't wonderful. Samuel, thanks for watching. Yeah, it was fun. Thanks for watching. It's midnight. You can go to bed. I record these things so that you can watch it later. You don't have to stay up for sure. Especially with the time change. Error 524. D message. Let's check that. All right. Default layout. Okay. So set default layout to 1 or 0. Okay, well, let's try that. Sudo. But that's not going to be sudo. What is it? Shoot. Sudo. Pasting random commands. Yes, that's always the best idea. Okay, so let's check if that's what it actually is. Cat. Okay, so it's set to 1. Let's try this again. Device or resource busy. Why is it busy? Super1.x can't open. You shouldn't be busy. Maybe because it's already mounted? Or I don't think it's mounted though. Mount. You don't have anything mounted yet. Well, the third try would be red shirt solution. Yeah. So let's see. Huh. Huh? There's nothing there. Okay. Red shirt Jeff is using all of the solutions. Well, this stinks. I want to get these all in RAID. I have to stop the existing. So here's the problem. If I stop the existing arrays, I can't. I mean, I could. So I could set these all into JBOD mode, like just a bunch of disks, and then do everything in software RAID. But I wanted to do the 4 RAIDs and then RAID the 4 RAIDs together. The reboot. I'll try a reboot. You know what? We'll just try that really quick. Sometimes with mdadmin, I do notice, like, if you do something and then it fails, then it like makes itself angry. Quentin is saying stop the mdadmin raids. I don't have any set up right now. So for anybody who's tuning in now or recently, I actually set up 4 RAID zeros for each set of drives. So there's 4 old SAS1, 4 old SAS2, and then 4 new SSDs, and then 4 old SATA drives. So I set up 4 RAID zeros in hardware, and then I want to put those together. So the hardware RAID makes SDA, SDB, SDC, and SDD. And I was thinking I could just use mdadmin and put those devices together, but they are RAIDs themselves, but they're not mdadmin RAIDs. So I don't know. Maybe it's not a great idea. Maybe that won't work. Yeah, so mdstat says I don't have any set up right now. I just installed mdadmin, so the only thing that I did was I tried creating a RAID 0 and it failed, so it's still initializing everything. The card is booting right now, and I can see all the hard drives are starting to blink and everything, so we're still getting logged in here. And none of the drives are mounted right now. Nothing is mounted. They're all just devices. Like I said, the thing is here, I'm trying to take 4 hardware RAID setups and RAID them together in software RAID. That might not be possible, but it's Pi Day, so I wanted to have a little fun and see if it was. So let's check now. So it's saying that there is inactive RAID 0. This is the one I was trying to create. So what will it say if I try doing it again? It says it's busy. So Yeah, so Zamboni Driver 42 is saying add the other drives to the first array. I mentioned earlier in the stream I can't do that in hardware RAID because hardware RAID is preventing me. It doesn't want you to mix like an old spinning disk with a new SSD, that kind of thing, or SAS with SATA. So I have to create the 4 separate RAIDs. Yeah, 4 RAIDs. What am I trying to achieve? I just want to make 16 hard drives in one RAID array on the Pi. Like I said, I could go easy mode. And do what everyone else does and just do one big software RAID array, but I wanted to get better performance with the hardware RAID. Of course it's RAID 0, so it's not going to make a huge difference anyways, but I was just trying to have fun, and I'm still trying to have fun. So somebody was mentioning try stopping it and try again. So I'll try stop dev md0. Okay. Oh, here we go. Let's try this. Unknown error 524. I have a feeling that we're going to keep running into this. But let me try it. What was the command that I did again? Nope. It was on Stack Overflow. Copy paste programming, best way. All right, so do this guy. Well, let's see what it is right now, actually. Cat. That, so it's 0. And I'm gonna, let's see. I'm gonna reboot and stop this again. Restart. Let's try that again. All right. DD each drive. Yes. JBOD is just a bunch of disks. I don't know if that's what you're saying or not, but yeah. I don't know. This is the way that I was thinking of doing it. The main reason I'm doing it through the hardware RAID controller anyways is I don't have any other cards that will let me connect 16 drives to the Pi. And I can actually connect more through here, but I'd need more hardware for that, which I don't have. Hashtag not sponsored, If somebody from Dell EMC or someone like that is wanting to send my way hundreds of thousands of dollars of gear, I would not be opposed maybe. I could definitely build that petabyte Pi. But anyways, that's why I was trying to do it the hardware RAID. And you can actually set the drives up in just pass them through to the OS. But I didn't want to do that because that just doesn't feel as cool. And Redshirt Jeff could definitely get these 16 drives to work together faster. I imagine that it would involve melting them down and then merging them into one, and then he would probably hand it back to me as a blob of metal. And the goal, what's the goal? The goal is to get 16 drives in one RAID array. That was the goal. There's another video that I'm working on. So I mentioned this earlier in the stream. Over here in the corner, there are a couple things that I'll be talking about in a future video. Ultimately, I'm just trying to play around with storage on the Raspberry Pi, learn some new things, have some fun, figure out ways that you could actually use a Pi in a way that makes sense and might actually be useful versus this is totally stupid. Don't do this. This is for fun, okay? This is not, I don't want you to build a solution for storage like this. But if you're somebody like me who likes to learn about something, like learn about how to build storage arrays and how they work, how hardware RAID works, this is a cool setup for it. Because like I said earlier, if you want to throw a giant PC over here, I couldn't even fit a server on my desk. So I'd have to go somewhere else like my workshop, and that's, there's dust there, and it's not I'm not going to walk over there during the day and test things and walk back and things. So this is all for fun. But I am going to talk about a setup that I'm building with Open Media Vault and 2.5 gigabit networking and SATA RAID, or software-based SATA RAID, using either ZFS or BTRFS or MDAdmin to build a RAID array for a NAS built with a Pi. And I'm going to show whether or not it's going to be faster / cheaper / better than an out-of-the-box solution like a QNAP or a Synology or Asus Store or something like that. So watch for that video. Subscribe to the channel for sure. But yeah, I'm doing it for fun. I'm not doing this to try to see if I can build I would never back up my important data to these 4 drives, which are probably at least 5 or 6 years old and have probably been in use for a lot of that time. These drives which shipped from Germany and they were in a box that was totally mangled. I would not trust my data on them. These 4 drives came from Micro Center used don't trust that. That would be a horrible idea. These 4 drives I bought new, and the only reason I bought them new was because they're only like 25 bucks or something. They're 120 gig Kingston SSDs. But I bought them new because I wanted to be able to saturate the bus using an SSD. So I have those 4 for testing. Anyways, yeah, totally for fun. Yeah, and the Pi NAS is going to be, I need to be careful with how I say that. The Raspberry Pi based NAS is going to be a lot of fun, for sure. How many times have I said pie? Well, earlier I ate that pie. It was very, very tasty pie. Let's see, a couple other things that I'll look at really quick. This is reboot, it should be finished. Another person asked way earlier about how much power does everything draw. So I actually tested that. The Pi and the card, I think it was 10 to 13 watts, 15 watts maybe when it was doing a lot of processing. So that was about 13 watts. And the drives, I didn't test this whole setup. I should have plugged in the kilowatt earlier. But this guy alone was like 40 watts or something, 35 watts. And this can use a lot more power. So these SAS drives use a lot of power. The SSDs don't use quite as much. But if you put in eight like newer, way faster SAS drives that were 15K or something, that's going to use a lot of power. So it is something to consider with the different types of storage arrays you build. That's another reason why I'm looking at the Pi for this stuff, is I can actually get a more energy efficient solution out of this Pi, depending on the card I use and depending on what drives I'm using, than a similar NAS solution. Some of the NASs, or if you're building your own, like a PC-based NAS, a lot of the PC ones might use 20 or 30 watts at idle. So that's a lot more power. If you're talking about running it 24/7 for all day, every year, that's a lot more power. You know, it's significant. You're talking about a savings there, especially if you're like me and you're looking in the future. I would like to have solar power for my house. If I can cut out half the power for every device in my house, that's kind of cool, because I could probably run off grid at some point. Anyways, yeah, lots of fun here. Let's log back into the Pi though and see what we can do here. The default layout is 0. I'm going to change that to 1 first before we do anything here. Make sure that that's 1. Okay, make sure that nothing is running there, and try to create this again. It's probably going to fail. Create array. Yes. Hey, well, look at that. It actually started. So look at this. It's actually working. Let's try this out. So we have a 3.6 terabyte. Oh, that'd be so cool if it was 3.14 terabytes. How much? So let's see. 3.6 terabytes in tebabytes. Wouldn't that be fun? Ah, shoot. I thought it was going to be tebabytes. Terabytes to... No, this is a terrible converter. 3.6 is... Oh, it's not 3.14. That'd be fun. Yeah, I knew it wouldn't be, but that'd be really cool if it was 3.14. Totally unplanned. Anyway, so we have a 3.6 terabyte RAID 0 volume. And to recap, we have 16 hard drives, 4 ancient SAS, 4 old SAS, 4 SSD, and 4 SATA spinning disk WD Green, super horrible performance. Tested these in another video. It gets like 3 megabytes per second if you're talking about 4K random write. Anyway, so these are all together. There's 4 RAID arrays. There's RAID 0, RAID 0, RAID 0, RAID 0. Those RAID arrays are controlled through here, and then I'm putting them all together in one MD admin RAID 0 array on here. And I had to do a couple tricks to get that to work, but it looks like it's working. So now let's change this file. I should have just typed it, because now I'm going back through history forever. All right, so we're going to do random read, and I'm going to change it to dev/md0. Let's see if this works. Save. Shoot, let's just go back. FIO random read. Let's see what happens. Now it should hit everything, and it is. I can hear. So I see everything blinking here. Everything's blinking here. Everything's over here. Let's see if we can hear it. Yeah, I can hear everything So let's see what it's doing. 117 megs per second. So it's funny. You know, you'd think if these are all RAID zeros and independently, the SSD RAID was giving me, you know, 399 megabytes per second, and the SAS one was like 160. No, the SAS one was like 220 or something. The one over here, and then this one was only like 120. Like you'd think that in aggregate you'd get more, right? But the problem is, and this is why. So this is why hardware RAID controllers like this are going to tell you, like, no, don't mix old SATA drives with old SAS drives with SSDs in one RAID array. That's a terrible idea, because the performance is going to be worse. So here's what we got: 124 megabytes per second, which is a fourth of what we got with just the SSDs. And even if you took one SSD by itself, that would be, you know, it would probably hit that saturation point too. So that was pretty bad. Now let's hit it with a write and see what happens there. And yes, this is all 16 drives, and I need to advance forward, sorry. We're benchmarking the mega RAID at this point. Let's go to MD0. Okay, so that's our RAID array, so LSBLK. These are the 4 hardware RAIDs, SDA, B, C, and D, and this is our RAID 0 software RAID using MDadmin. 3.6 terabytes. It would be so cool if that was 3.14. But, I mean, it's close. We'll round down to 3.14. So now let's run this write test. And I'm going to be quiet this time, so I'm going to hit go. I'm going to take this microphone off of me. And sorry if you hear the noise of that. But I'm going to hold it up. Thank you very much. Oh, sorry, I missed somebody's super chat. If somebody wants to pop in there what you said, I'll definitely say it. But thank you for the nicely done there, Citizen Gold. I remember earlier you said that you would do that, so good on you for making good for your word. So I'm going to do this. I'm going to switch over to the desk, and hopefully I'll be able to hear this. Man, that sounds bad. Yeah. Yeah, that sounds pretty bad. Like I said, don't buy a bunch of old drives and put your important backup data on it. Although, if you're going to use RAID and you have a good 3-2-1 backup plan, for example, right now, so my ulterior motive, I'll just let that keep writing, but I'll switch over here. My ulterior motive is I'm going to have a RAID array over here, probably under the desk there. That will be my primary NAS storage for video work, because now that I'm doing videos every week, I have maybe like, I don't know, 20 to 40 gigabytes of data in a given week that I'm writing out. Sometimes 50 or 60 gigabytes if I'm working on a huge video, then I have a lot of footage to cut down. So I have that, and I have it back up nightly, and it's running through this little Mac Mini that I've had running since 2011. So it needs replacement. The OS is not supported on it anymore, but it runs a nightly backup script that backs everything up to an S3 Glacier-backed drive on Amazon, and I have, I don't know, 3 or 4 terabytes, maybe 4 or 5 terabytes now of data on it, and so it backs that up. You know, if I do 20 gigs of footage in the day, it'll only take a few hours to upload that, so it does that overnight. So that's my current solution. But I don't have an active backup on site, and this Mac is not using RAID. So if the drive, I have 2 8-terabyte drives connected. If one of those fails, I'm going to lose all that data, and I'll have to wait to bring it back down from the cloud, and that's annoying. And you know, now that I do all these videos, I don't want to have to do that. So eventually, I'm going to have my little NAS RAID, and that'd be cool. It's 4:20. It's not 4:20 yet. We got 2 minutes. All right, so let's see. What did we get here? We got 254 megabytes. It's funny, the write speed is twice as fast as the read speed, random read, which is weird. I don't know why exactly that is. It must have something to do with the way the software RAID is working. But so another thing that I do a lot of times when I'm working on this to see if the pi is actually the bottleneck. Pi sudo atop. So let's switch it to 2 seconds. So let's glance at ATOP and see what the Pi itself is showing us when I do, let's do the read test again. Random read. So it's running, hard drives are going crazy. So we can see that it's lighting up here. The latency isn't too terribly bad. You can see, you can actually see by the latency which drives are which. This 13.1, that's SDA. Wait, which one? Ah, it keeps moving. SDA, that is these drives. So they're definitely having some hard time keeping up with the seek time. But anyway, it looks like the Pi itself isn't hitting any IRQ limits. CPU's not overloaded. I mean, it's RAID 0, so that it doesn't have to do a whole lot of work. It's just pumping through the bits. But it looks like the problem is that these drives are just slow in aggregate when you're trying to do this, because it's trying to distribute the writes equally amongst all 4 RAID arrays, and that's not going to be super fast. That's why you don't have enterprise storage where you mix old drives and new drives as much. I'm sure people do it though. Anyway, so yeah, it looks like everything worked. I'm happy there. And I'm going to glance here and see if there's anything else going on here. And then I'll give a recap and everything. But again, I want to mention, please support the Pi Foundation for their work in education and computing. And like I said earlier, a lot of people don't understand, but the Pi Foundation itself is separate from Pi Trading, which makes the hardware and sells the hardware and things. So a lot of people are like, well, I don't need to donate to the Pi Foundation because they make tons of profit on these devices and things. But they're split up for a purpose so the Pi Foundation can focus on their educational mission. And another thing that some people might think, like, I'm not affiliated with Raspberry Pi in any way whatsoever. I know a few of the people there, and I love working on Raspberry Pis because they're fun and they don't take up much space on my desk. But I just enjoy working with them. When am I going to do the Ender printer video? I actually am working on that right now. It's a long-term project because when you do 3D printing, you end up like if you have a mistake, it's going to be another 6 to 8 hours before you can see the results of any tweaks that you made. So 3D printing is a lot of waiting and then changing and then waiting and changing. And I'm still trying to learn some CAD. That's something that it's a lot different than just Illustrator. Like, it's Illustrator squared. That's what I feel like CAD is, and I'm still trying to pick up the tools. How many Pis do I own? Somewhere around 16 to 18. Am I using Octoprint? Not yet, but my plan is that I might set that up on a live stream because I'm interested in using Octolapse or Octotime-lapse or whatever. All right, so quick recap. We have 16 hard drives. 8 of them are SAS. All of them very old. These are super old. 4 are SSDs and 4 are SATA hard drives. WD Green, super old. Don't use these for anything important, especially if you bought them used at Micro Center. They're all connected to the Raspberry Pi through a MegaRAID 946069, I think. I don't remember. This was sent to me by Broadcom. Thanks again to them for sending me this and helping with the driver issues to get it working. It's connected through a backplane to these drives. This was also sent by Broadcom. And I don't have a U.3 drive to test, or even a U.2 drive. I'm still trying to work on getting some of those. But the cool thing about this setup is it lets you put in any kind of drive, basically, and it sorts out how it works. And it can work with U.2, U.3, NVMe drives through U.3, or an adapter with U.2, and SAS and SATA. It's really neat, the whole way this is set up. And I hope to explore that more in a future video, but I'm waiting to see if I can get some more drives to work with. Anyways, it also is plugged in through these cheap cables, mini SATA HD or something like that, to SATA/SAS, and it's connected to these drives and those drives that way. It's running on the Raspberry Pi Compute Module 4. This is the light version, so I'm booting off this micro SD card, just connected through 1 gigabit. Now, this is something I'll be talking about in a video coming up soon. I actually have. I've found a way to get a PCI Express switch to work with a 2.5 gig Ethernet card and a storage controller. Not this one. I can probably get it working, but I haven't tried with this one yet. Mostly because I tried getting this thing working. But I'm going to try to build a 2.5 gig NAS using the Raspberry Pi Compute Module 4, kind of as a proof of concept to see how fast it is, to see how easy it is to build. and then we're going to take that and compare it to an off-the-shelf NAS, talk about some of the benefits and drawbacks. So watch for that. Please subscribe, and please, if you want to rewatch this video, go ahead and do that. Fusion, it was Fusion 360 was the 3D printing software I used. Anyways, it's getting a little bit later and my throat is starting to die. So I'm going to wrap up the live stream there, and it was awesome. Thanks for everybody for watching, and please consider donating to the Raspberry Pi Foundation. Happy Pi Day. It's been great talking to everybody, and if you have any more questions, please feel free to pop them in the comments or ask me on Twitter or something. There's a lot more fun things that I think I can do with this setup. Now that I have everything working, and now that I know that I can get it working, there are some other fun things I would like to do at some point, and we might see some of those in the video. Anyways, until next time, I'm Jeff Geerling.